Recording in progress.
Okay, so let's do a 5-minute summary of what we got, okay? Okay, so these are the equations you started with. They're in red, yeah? Okay. So maybe we call this 1, 2, and 3, yeah? Okay. When you expand these equations, okay, you get these equations, yeah? Yeah? That's what we did, remember? And then when we add those equations together, we get this equation, which simplifies after cancelling by 2 to this equation, yeah?
Yes.
Okay, and the nice thing about this equation
That's
is
33.
I won't times it out. But yeah, the nice thing about this equation, it has 3 terms plus 3 terms, and every of the original expanded equations has 2 of those 3 terms. Yeah?
Yeah.
So if you subtract like these ones here from this one, right? Okay, you get these 3 equations. Yeah? You agree? Okay. And then if you times each equation by like C, so this one times the first one by C, times this one by B, and times this one by A, right? You see? Then you get these 3 equations, yeah? Okay.
So you can also say like, that equals.
Yeah. Yeah, so because ABC is the same in all of them, right? Like this is your K, right? So you have K plus C squared minus 11C equals 0, right? You have K plus B squared minus 11B equals 0, yeah? K plus A squared minus 11A equals 0. So what that means is all of those A, B, and C, they satisfy this quadratic equation. Let's use the letter Y here. So it's K plus Y squared minus 11Y equals 0. Okay.
And what's Y again?
It's the variable in the equation.
Oh. I'm dumb.
No, you're not dumb. That's the fundamental difficulty of this topic, okay?
Oh, I'm dumb.
The fundamental difficulty is you're dumb. It's like, is you're learning the wrong thing.
Already?
No, we got it from this.
Where? Yeah, we had that equation written up there.
Yeah, we did.
Yeah.
This is a summary of that, right?
Okay.
And here K is equal to ABC, right? So no matter what A, B, and C are, right? You get that they satisfy this quadratic equation, okay? Right? And a quadratic equation has most 2 solutions, yeah?
Yes.
So that means 2 of them have to be the same, yeah? Okay, and when 2 of them are the same, either all 3 are the same, or it's equal to 1, 1, 10, right? We solved that before.
Yeah, so I'm correct?
No. What we proved before, so what you did was you assumed they were integers, right? What we proved was that solving them as if they were integers was equivalent to getting the solutions for when exactly 2 of them are the same, right?
No, but then, so the answer is 11.
I think the answer is 11, yeah.
So you proved that it can't be all of them are different?
Yeah, they can't all be different.
Okay, good. I get it now.
Yeah. But your answer was 12, wasn't it?
Yeah.
Yeah. But good, you get it. That's the good thing.
What was the answer? 7. Oh, yeah, okay. I forgot about that. Yeah, lots of 11, so therefore the answer is 11.
Okay, so I mean the thing that sucks about this question is that if you'd never even considered the possibility that they were all different, okay? So basically, if you just considered if they were all the same and they were all integers, okay, you would have got the right answer, okay? But like there are ways to prove that they can't all be different, okay? And this argument is like super weird, okay? It's like you have to convince yourself there's actually just one equation going on, right? So just think of ABC as numbers, right? Yeah. And therefore K is just some number, right? Which doesn't depend on A, B, or C. And then this equation is true for A, B, and C, yeah? So it can only have two solutions, right? So it's a super abstract argument, which actually you don't even need to get the right answer. You just need to be sure that it's the right answer. Okay? But being sure it's the right answer is the quality in the mathematics. Okay? It might not have any value for a badly written question in a bad exam. Okay? But in the long term, it's worth everything. All right? Okay, so then this brings us to basically the case where two of them are equal, right? And I think if two of them are equal, you could probably just go from here and do an exercise, yeah? It's like go from here, assume A equals B, yeah? And we did that, I think, before, right? If A was equal to B, then you get A squared plus C equals 11, and then the other two equations collapse into one, right? Yeah? And yeah, it's the same. If they're equal, you can cycle the solution. So if there's some other two things that are equal, then you can still assume A equals B is equal after cycling. Yeah. All right. Okay, and then if all three of them are equal, so this is where we get like this situation here. And you don't actually have to solve it using the quadratic formula. You just need to know that the sum of the solutions of the quadratic is equal to negative of the first coefficient. So you know they have to add up to -1, right? So you get exactly two triples for which they're all equal. Yeah? And the sum of those A's is -1.
Thing I got, but simplified. Why would there be two triples? Oh,
Because there's
yeah, okay.
plus and minus, yeah. Okay, so then and then we proved that assuming there were integers is also equivalent to getting the case where two of them are equal, the third one isn't, right? So that's a way to prove that that thing actually is worth points because you got like, so all the solutions, there's like two solutions from there, right? And then there's like three solutions, which is 10, 1, 1 cycled. Yeah. Huh? If what? Yeah. Oh, that's a good question. So the question was, if you say the equation is cyclic, would you get a point? Yeah. And this is one of those interesting situations where it's like, it's not necessarily concrete enough to be worth a point, but it's definitely like
Worth writing.
it's definitely worthy of like respect. Like the person who reads it is happy. Like it's worth like it's more than a point almost in terms of respect. Okay. If I was marking, right, I would give you a point for sure if you're doing badly in the exam. If you're doing well in the exam and that's all you wrote, it's hard to justify it's worth a point.
But that's not fair. You shouldn't give them a mark on based on whether they're doing well.
Yeah, no, you definitely
Consider the
should.
mark individually.
No, but basically when I do that, it's basically when someone's kind of like basically disqualified. Like they're out of the running for any. It's more just encouragement points. But if you wrote that the equations are cyclic, I would think it's worth a point. Okay. But the problem, though, the reason it might not be worth a point is not very concrete. You know what I'm saying?
But it's so obvious.
Yeah, but it's not. But it's obvious, but it's also very helpful. Yeah. See, it's yeah, helpful equals points. Lack of concreteness equals not points. Yeah. Okay, so that's it. Any questions? We take our dinner break. Keep looking at questions 7 and 8.
Question 7 was weird.
So I would think this is a pretty tricky question. I mean, even though it was really easy to get the right answer, I think it's hard to solve it completely mathematically. Yeah. Yeah. So like in the exam, this could take like 5 minutes to solve, but like it would take you quite a much longer to be sure and write up a proof. Okay.
That's his. Wait, my